Hey everyone, we're going to talk about making sense of proofs. So here is our first example. We have a sketch, and let's get Mr. Zamora out of the way. We have this sketch, and we're being asked to prove something, and I don't have the statement up here that tells you what you're set out to prove, but bottom line, originally it had, you're set out to prove that these two triangles are congruent. So we got to think about how you're going to do this. On your own time, you can look at the proofs tips that I've provided, but I find that rather than jumping into selecting a type of statement and then a reason and this, you need to make sense of the picture first. So let's make sense of that. All right. So we've been told that AE is parallel to FD. So that's these little marks right here, all right, that they're parallel. Okay. We're also being told that AE is congruent to FD. Okay. So we've got those marks. Then it also says AC is congruent to BD. So AC is this side. It's kind of like, I know these are not necessarily listed as right triangles, but it looks like it could be the hypotenuse of AEC. All right. Again, we're trying to prove that triangle AEC is congruent to triangle DFB. DFB. Okay. So we're told that these two sides are the same. So I can put a little mark like that. All right. And it's hard to show the mark because it's on a shared side. All right. But this side is congruent to that hypotenuse. Okay. So we proceed. Is this enough information for me to say that the triangles are congruent? Well, having two sides the same, knowing that this side is, that these two sides are the same for the two triangles is not yet enough. So there's no side-side theorem of congruence. So we got to think, is there anything else that I could conclude about these triangles? So let's focus right here on these parallel lines. So if these are indeed parallel lines, then technically this horizontal line right here, or line segment, is a transversal. It's going to be a transversal. So if you remember your angle properties for transversals, you'll remember that alternate interior angles, which would be these guys, alternate interior angles are equivalent. So we're going to be able to say that these two angles are the same. So look at what we have now. We have a side, an angle, and another side corresponding on both triangles. Side, angle, side. So the two triangles are actually congruent, and they're congruent by side, angle, side. All right. Now I didn't write down my steps very clearly, but this whole time I tried to make sense of it. So look at the way that I went about it. I made sure that all of my given statements, that I was able to visualize them, right? Next, I made sure that I knew what I was trying to prove. And actually, this should be the first thing. I need to know what I'm trying to prove. I need to visualize my given statements. And then once I'm looking at this drawing, right, I need to think, what other conclusion could I make? So I made a very bold conclusion right there, or inference, saying these two angles have to be the same. All right. Now, to finish actually writing the proof, we would put down into steps what we discovered. So it would look a little bit like this. Like this. I went with my given statements. I labeled them on my drawing. I then said, okay, well, look, angle A is congruent to angle D, right? And I got to have a reason for it. My reason is that they're alternate interior angles. And then I said, well, hey, wait, now that I have corresponding side, angle, side for two triangles, they must be congruent. So I said the two triangles are congruent. My reason is side, angle, side, the side, angle, side postulate. All right. That is my proof. All right.